Welcome to another video, everybody. Today we're talking about triangle sum properties. By the end of this, you should be able to use theorems that relate to angle measures in a triangle and to classify triangles based on side lengths and angle measures. So let's get started. First thing we're going to do is learn how to classify triangles and review a little bit of this. These three words are ways that we can classify triangles by sides. A scalene triangle is one where all three sides have different lengths. So let's say this one, for example. The way that you can indicate that all the side lengths are different is by putting a different number of lines through each side. That indicates that they're all different lengths. So that'll help you out in expressing that it's a scalene triangle if you need to. An isosceles triangle is a triangle where two side lengths are equal. So let's say that we have this going on. Then what we would do is mark the two sides that have the same length with one mark, and then mark the side that has a different length with a different number of marks, like 2 marks. And finally, equilateral triangle, all three sides are the same length. So these triangles all are similar to each other. They all have 60-degree angles and all their sides are the same length, which we can indicate by putting the same number of marks on each side. So that's how we classify triangles by side length. By angle is something we've already discussed, so I'll just run through it really quickly. Acute triangles have 3 acute angles. Our equilateral triangle from just before is actually a really good example of one, because all the angles have to be 60 degrees. A right triangle has 1 right angle. And remember, the easiest way to indicate that we have a right angle is to put that mark there. And then we have our obtuse triangles, which have, or has, 1 obtuse angle. So that's going to look something like this, where the angle I'm labeling right now has a measure of over 90 degrees. And that's what makes it obtuse. So, kind of sped through that part because we've seen that pretty recently. And we will move on to a few theorems. First theorem, triangle sum theorem, is an idea that we've used quite a bit as of late. Let's say that we have a triangle, and it's not any special kind of triangle, but there it is. And let's call it ABC. The triangle sum theorem tells us that the measure of angle A plus the measure of angle B plus the measure of angle C all add up to 180 degrees. Something you probably already knew and have been using quite a bit in recent days. So, in this problem, in this example, it says classify the triangle by its sides and angles, then find the value of x. Well, we can see that 2 of the angles have the same measure, 2x plus 2 and 2x plus 2. And we also can see from the markings that 2 of the sides have the same length as well. We see it from this and this. So what that means is we have an isosceles triangle, and we also know, well, we don't know about the angles yet. I guess we're going to have to find the measures to be able to tell for sure what's happening with this one. So we will go and do that. And the way we're going to do that is by using this triangle sum theorem that we have. So what we're going to do is we're going to take our 3 angles, and since we know they have to add up to 180 degrees, we're going to set them equal to 180. So we're going to have 2x plus 2, that's our first angle, plus 2x plus 2, plus 3x plus 1 equals 180. And really the parentheses are just there so you see where the numbers are coming from. It's these angles that we have. What we should do, though, is combine like terms. So this 2x, and this 3x will be able to combine. And 2 plus 2 plus 3 gives us 7. So we'll have 7x. And then we should also combine this 2, and this 1. And those combine into 5. So we have 7x plus 5 equals 180. So, next step is we're going to have to get rid of the plus 5, so we'll subtract 5 from both sides. Minus 5 gives us 7x equals 175. Divide both sides by 7, and that gives us that x equals 25. So, what that means then is this angle up here and the one next to it is going to be 2 times 25 plus 2. That's 50 plus 2. So 52. This one over here is also 52. If we add those together, we get 104. 52 plus 52 is 104. And 180 minus 104 gives us 76. So that's the size of this angle. We can see that these are all acute angles. They're all less than 90 degrees. So this is an isosceles acute triangle. So we actually have all the information we need at that point because we were asked to classify the triangle. We know it's an isosceles acute triangle, and we found x, which was 25. So that's that problem. All right. Second theorem that we have. So imagine that you have a triangle, and we extend one of the sides just a little bit along this line. Well, remember that there are two objects in this picture that have 180 degrees about them. There's this triangle where if you add up the angles, you're going to get 180 degrees. But there's also this line. Like if I choose this point and I make this straight angle, we know that the angle from the triangle and the angle outside of the triangle also add up to 180 degrees. Notice that this angle that I'm about to label in green overlaps between the triangle and that 180 degree angle, or 180 degree, straight angle. So, because that's true, since both objects add up to 180 degrees, that means that this angle here on the outside of the triangle has to equal the same amount as this angle here, let's call it angle A, and this angle here, angle B. Let's call this one on the outside angle C. So basically what I'm saying is the measure of angle C is equal to the measure of angle A plus the measure of angle B. So, it's called the exterior angles theorem because this angle, angle C, is called an exterior angle. And we're saying that C is equal to the other two angles that are inside the triangle. So if you look at the example that we have, this is one setup of it. We have 4x plus 8 on the outside of the triangle, and we have 51 degrees and 2x plus 3 on the inside. And what this theorem says is that the angle that is 4x plus 8 over here is going to be equal to 2x plus 3 plus 51. In other words, the two angles inside the triangle that are not attached to that x angle on the outside. So, simplifying this, we get 4x plus 8 equals 2x plus 54. Number of ways you could solve this, but I'm going to subtract 2x from both sides, giving us 2x plus 8 equals 54. Then subtract 8 from both sides. Oops. Minus 8, giving us 2x equals 46. And then dividing by 2 on both, we get x equals 23. Now once we have x, we can plug it back into here to get our exterior angle. 4 times 23 plus 8. And what that's going to give us then is 92 plus 8, which equals 100 degrees, and that's the measure of the exterior angle. So, that's about all I have for you on this video. Thanks for watching. Hope you learned a lot. See you in another one.